Okay, let's have a look at this one, guys. So we got a golf ball that's initially traveling at 25 meters per second, okay? They give me a speed there, would you agree? I was never told the direction here, and that's okay, right? All I know is that VI is 20 meters per second, okay? It hits a sand trap and slows down with an acceleration of negative 20 meters per second. Now, I don't like the way they wrote that. Okay? If this were me, I would say slows down with an acceleration of 20 meters per second squared. Because by putting the negative in there, is it negative slowing down? Because negative slowing down is speeding up. Okay? I say slowing down, you got to know that's a negative number. Okay? By putting the negative in there, in my mind at least, because I'm old and confused, okay, I look at that and go, negative slowing down is speeding up. Just like negative left is right. And negative right is wrong. Or left, whichever. Okay, so I'm going to put in here that yes, acceleration is negative 20 meters per second squared because that's what slow down means. Okay, find its displacement after 2 seconds. Okay, weird that I'm going to be looking for a displacement when I don't have a vector on my velocity. I'm just going to have to assume, or on my speed, sorry. I'm just going to have to assume that it's forward, okay, which is a safe assumption. Okay, which formula are we going to use here? Looking for D, I've got V, I, A, and T. Looking on your formula sheet, which one should I pick? Sarah, you got one? Yeah, which one? Which formula should I use?
D equals VI times T plus 1/2 AT squared.
Awesome. Exactly that one. Okay, because this is the one that's got all the things I have and the thing I'm looking for. And even better news, I don't have to manipulate it. It's already set up for D. So all I have to do is plug in my numbers. All right, so that's going to be VI 20 times 2 seconds plus 1/2 times negative 20 times 2 seconds squared. Okay, so if I punch all of that in, okay, I'm going to have 40 here, plus negative 20 times 4, negative 80, negative 40. All right, let's punch it all in here. So we got 20 times 2 seconds. Okay, and we're going to add that to 0.5 times negative 20. Okay, oh, sorry. This is supposed to be 25. No wonder that didn't work out. You guys got to tell me when I screw up. It's not going to embarrass me. It's more embarrassing for me to discover the screw up, okay, than it is if you guys tell me. Okay, so I think we're looking at about 10 here, right? Okay, so we got 25. Let's try that again. 25 times 2 plus 0.5 times negative 20 times 2 squared. Okay, so it's going to travel 10 meters forwards. Okay, how do I know it's forwards?
It's not a negative number.
It's not a negative number, and even though they didn't tell me what direction it was initially traveling in, the context of the question tells me that. Okay, nobody hits a golf ball backwards into a sand trap. Okay, the context of this question, okay, indicates that the ball must have been going forwards when it hit the sand trap. That's part of what we're trying to kind of teach you guys how to do, is read into a question a little bit. Sometimes stuff isn't explicitly stated, it's implicitly stated within the context of the question. Okay, everyone follow me there? Right? We can all imagine a golf ball rolling forwards into a sand trap. Okay, I've never seen a golf ball roll backwards. Well, off the green, I guess, but yeah, we kind of got to go with that context, okay, of the question there. Okay, everybody okay with that? All right, let's look at that formula just quickly here before I have you try and use it yourself. Okay, D equals VI times T plus 1/2 AT squared. All right, let's say I wanted to solve for VI. What should I move first?
the 1/2 and the acceleration in time.
Yeah, I can move that whole thing over at once. Would you agree? Right? I can subtract 1/2 AT squared over to the other side because I would know what that number is, right? Order of operations says I would do this whole thing before I add it to this. So I can subtract that over. All right, that'll be my first step. D minus 1/2 AT squared, okay, equals VI times T. All right, how do I get VI by itself? Divide by T, right? Okay, now here's where people will sometimes make a mistake. Will this T and that T squared cancel each other? No. Okay, but a lot of people will make that mistake because they see a T on the bottom, T on the top, and they cancel. They only cancel if everything on the top is being multiplied together. Because there's an addition and a subtraction operation, I can't cancel those things anymore. Okay, so I have to do the top and then divide by the bottom. Right, but now I'm solving for VI. Okay, everybody good with that? Okay, let's start it over. I want to solve for A. What should I move first? Megan, what should I move first?
The VI and
Exactly. I'm going to subtract it over to this side. All right. D minus VI times T equals 1/2 AT squared. All right. I want A by itself. What do I have to do? The half and the T squared. Right now they're being multiplied. I need to divide. Yeah, do the opposite. Okay, so I divide both sides by half of T squared. Those are going to cancel. 1/2 T squared. I'm solving for A. Okay, just algebra. Okay, you're going to have to flex those muscles now. You probably haven't used them for a while. Okay, but you're going to use them a lot here. Now I'm solving for A. Okay. What if I want to solve for T?
Which one would you solve for?
That's the question, right? T's in two places in this equation. Does that make it trickier?
Would you just solve for the normal T then?
Well, actually, here's the good news. Because we haven't, or we can't guarantee that you've done math 10 or math 20 where you learn to factor and do quadratics, okay? You don't have to solve for T using this equation unless VI is 0. Why can you solve for it more easily if VI is 0?
So it'll cancel out the T with the
Exactly. VI times T, if VI is 0, is 0. And 0 plus anything is itself. Okay? So if VI is 0, all I have left is this. That T is gone. Now I can solve for T. Okay? I would isolate T by dividing both sides by half of A. And then square root. Okay, so for this formula, you won't have to solve for T if VI is anything other than 0. Okay, because otherwise you would have to factor and do all that other math stuff. Okay, which we're not about here in physics 20 at least. Okay, everybody okay with that? Everyone can, it's because I think you all figured out that that's probably what was going to have to happen. Okay, if you're like me, there's like a trauma response to that. Okay, my dad yelling at me at the kitchen table. We're trying to do my math homework when I was your age. Yeah. Okay. Questions on that formula then? Okay. I want you guys to try these two. Okay, they both use that formula. Yeah. Okay, you can do both of those. Okay, give you a few minutes on that one. Those are pretty straightforward. Okay, and then we'll go through them together. Okay, so for number 1, okay, we got a skier moving down a slope at 3 meters per second. Okay, so VI is 3.0 meters per second downhill. Okay, the acceleration down the hill is 4 meters per second squared. Okay, find the skier's displacement after 5 seconds. Okay, so I've got everything there. I don't even have to manipulate. Okay, VI times T plus 1/2 AT squared. Okay, so just punching in here. So I've got 3 meters per second times 5 seconds plus 1/2 times 4 times 5 squared. Okay, so 3 times 5 plus 0.5 times 4 times 25. Okay, so 65 meters downhill. Okay, if you forget to write downhill, do you get the answer right? Okay, it's a vector quantity. Displacement needs a vector. Okay, and it would have to be more than positive. Okay, the question specified downhill, you have to specify downhill. Okay, in number, how many people have done number 2? Okay, so you got to do that divide by 3.6 thing here, right, to get it back into meters per second. Okay, so we got a motorcycle traveling at 100 kilometers per hour. Okay, so if we go 100 divided by 3.6, we're going to get 27.7 repeating. So there's our VI. Okay, on a flat road, and it applies the brakes at 0.8 meters per second. Okay, context here. My acceleration is negative. Okay, and this is what you kind of have to think about, because sometimes people don't think about that when they do the question, and then at the end of the question, their final velocity is bigger than their initial velocity after having pressed the brakes. That's bad. Okay, if you press the brakes and you go faster, you're in real trouble, because I don't know how you're going to slow down. Okay, so always kind of look at it, look at your answer, and then go back to the context of the question and go, does that answer make sense within the context of the question? You'll often find you'll catch yourself, okay, because you just kind of had an idea in your head and you went with it, and then you realize after, you're like, oh wait, that should have been negative. Okay, always go back and kind of double check that. All right, so 0.8 meters per second squared is our acceleration, and it does that for 1 minute. Got to put that into seconds. 60 seconds. Okay, how far did the motorcycle travel during that time? All right, so we're looking for D. Okay. Again, don't have to manipulate here. VI times T plus 1/2 AT squared. All right, so we're looking at 27.7 times 60 seconds plus 1/2 times negative 0.8 times 60 squared. Okay, we do that. We should get about 230 meters, I think. Okay, so take that number there and multiply it by 60 plus 0.5 times negative 0.8 times 60 squared. Yeah, so to 2 significant digits, because that's all we have in that question, it would be 2.3 times 10 to the 2 meters. Okay, because the 6 would round up the 2. Everybody with me there? Okay, lots of times you're going to use scientific notation in this class. Okay, any questions on that formula? Okay, will its counterpart that we went over the other day work the same? It will, right? The VFT minus 1/2 AT squared. It's going to work very similar, and just like that one, you'll never be asked to calculate time if VI isn't 0. In the prep room.
Sorry.
Okay, so that formula then that we're talking about, okay, its counterpart, the D equals VF times T minus 1/2 AT squared. Again, it works exactly the same as this one, except you're subtracting and you're using VF. The manipulations are all the same, and you won't be asked to solve for T unless VF is 0. Okay, but in that case, if VF is 0, do I still have to keep this negative here? I do. Okay, so I'd actually go 0 minus. I'd have to make sure I keep that negative there, okay, when I'm using that one. Okay, copy that one down, and then we'll go through it together here. All right, so on this question, again, context is important. If I'm in a boat and I'm moving forward, and then I start to slow down, my displacement while I come to a stop, forward or backward? Forward, right? I still move forwards as I slow down, okay? It's something I kind of have in the back of my mind if I'm looking for the displacement. So what I have here, okay, is I have slowing down at a rate of 5 meters per second squared. That's the way I would say it in a question as well. I just have to know that that number is negative. It's going to have to be mathematically. Okay, so it's slowing down, so my acceleration is negative 5.0 meters per second squared. It comes to a stop, so VF is 0 meters per second. Okay, and it takes 15 seconds, and I'm looking for the displacement of the boat. Okay, so that's what I've got. I would have to use then this formula, D equals VF times T plus, or sorry, not plus, minus 1/2 AT squared. I don't have to manipulate it in this case, I'm looking for D, right? But I need to plug in my numbers. 0 times 15 minus 1/2 times negative 5 times 15 squared. Why do I want to keep that minus in there? I want to subtract a negative number so I get a positive displacement. Okay, so this is what I was talking about on the last slide. It's like, guys, if VF is 0, you still have to put it in. Okay, that way you get the right sign on your answer in terms of vectors. Okay, so I'm going to have, okay, when I punch that into my calculator, I keep that 0 in there, or I do this. Okay, I could also do this. I could go negative 0.5, okay, times negative 5 times 15 squared. Okay, I could do that, and I would get the same number, okay, as if I go 0 times 15 minus, okay, 0.5 times negative 5 times 15 squared. Okay, I just have to remember that negative is there. If I don't, then I'm going to get the wrong vector on my answer. Okay, everybody all right with that? So that one there, we would have, how many significant digits for my answer there? 2. Everything I was given has 2. All right, so how do I write this number, 562.5, as a 2-digit number?
5.6 times 10 to the power 2.
Right, 5.6 times 10 to the power 2. Meters, okay, and I would say that that would be, as a vector, forward. The context of the question would indicate that. Okay? Questions on that one? All right. Okay, I want you to try these two, okay? You can do them both, even though the top one asks you to solve for time. All right, so if you've seen like Top Gun, you've seen how planes land on an aircraft carrier. It's quite a violent thing, actually. Okay, they kind of slam down onto the deck, which is of course moving because it's a boat. Okay, and then they catch these arrestor cables, right, which are actually connected to big steam-driven things under the deck. The same system that launches them, that powers the catapult. Okay, so they experience a fairly large acceleration here, negative 15 meters per second. That means that they get thrown into their harness, okay, with an equivalent force of 1.5 times their weight. Okay, so they would actually feel like someone that's 1.5 times heavier than them is standing on their chest for a minute, okay, while they're being slowed down. It's a violent thing. There's got to be like an onboard chiropractor, okay, on an aircraft carrier for these guys, because that big heavy helmet snapping forward, okay. It would be like running into something in your car when you're going, 60 kilometers an hour or faster, and then, coming to an immediate stop. Okay, so we know that the distance that they travel is 150 meters. Okay, and we know that their acceleration is negative 15 meters per second squared. We want to find the time that it takes, okay, for them to come to a stop. So if they come to a stop, VF is 0. Okay, so we've got d equals vf times t minus 1/2 at squared. Since vf is 0, what's vf times t? 0. All right, so I'm just going to substitute that and go 0 minus 1/2 at squared. Is that going to make my life a little bit easier now solving for t? Because now I only have 1 t to solve for. Okay, so what I usually do at this point is I just go, I'm just going to remember that negative is there. I'm going to pretend this 0 isn't. Okay, and I'm just going to start moving things around. I want to solve for t. So I'm going to bring negative 1/2 of a over to this side. So basically I'm dividing both sides by negative 1/2 of a. Okay, that solves for t squared. What do I want? Just t. All right, so I'm going to square root this. Okay, looks a lot like what I diagrammed for you on a couple of slides ago, except there's a negative there now. Okay, now this is where you'll know if you forgot the negative. Okay, because if you forget this negative and you punch this in, what's your calculator going to do?
An error?
Yeah, it's going to freak out on you, man, because it's going to say you're trying to take the square root of a negative number and that's impossible. And it's absolutely right. It is impossible to take the square root of a negative number. So if you don't bring this over and you make a negative, you're going to try and root a negative number, which obviously is not possible. Okay, so now that we've got it manipulated, we're going to put in, was it 150 meters, right? Okay, 150 meters. Okay, divided by 1/2 times negative 1/2 times negative 15. Okay, and now we can punch it all in. Okay, so if we punch that in, we should get a good number here. So square root of 150 divided by negative 0.5 times negative 15. Okay, what did I do wrong here? Oh, I didn't do brackets. Hang on. 150 divided by, in brackets, negative 0.5 times negative 15. Better. Okay, I forgot to, see, my calculator did order of operations when I didn't want it to because I forgot to put brackets in there. All right, so we've got now well, we only have 2 significant digits there, so 4.5 seconds as the total time. Okay. Everybody okay with that? How many people have done number 2? Okay, I'm going to give you a couple more minutes on number 2. Okay, you're looking for the acceleration there, but remember, you've got a kilometers per hour there, so you got to do that 3.6 conversion. Okay, so looking at number 2 here, okay, we have a 1968 Corvette, took 6.2 seconds to accelerate to 160 kilometers per hour. Context, that's fast. That's 100 miles an hour. Okay, most passenger vehicles can't get to 60 miles an hour or 100 kilometers per hour in 6.2 seconds. Okay, this thing was a beast. Okay, it had a big giant big block V8 in it, okay, and it just guzzled gas. Okay, if you press the gas down, you could watch the gauge go down. Okay, it was really, really thirsty. Okay, but it was also really, really fast. Okay, so we know that the time involved here is 6.2 seconds. Okay, and the final speed is going to be 160 kilometers per hour. So we do have to turn that into meters per second. So we'll take the 160 and divide by 3.6. Okay, 44.4. Okay, and it goes 220 meters in that time. So around probably about a quarter of a mile. Okay, so D, 220 meters. Okay, find the acceleration. So we're looking for A. So again, more algebra with this formula. All right, so we got D equals VF times T minus 1/2 AT squared. Okay, if I'm looking for A, first thing I want to do is what with VFT? Subtract it over to the other side. All right, so I'll start out with D minus VFT equals negative 1/2 AT squared. So I'm looking for A. What do I have to do with the half and the T? Divide them over. Okay, so divide by -1/2 of t squared. That comes over to this side. Okay? Again, bringing that negative over is important. Okay, now I'm solving for a. So I put in my numbers here, 220 minus 44.4 times 6.2 divided by -1/2 times 6.2 squared. Okay, so a bit of a mess to punch into the calculator here. Okay, so 220 minus 44.4 times 6.2. Okay, so there's the top, and I'm going to divide that by the bottom, -0.5 times 6.2 squared. Okay, so the acceleration there to two significant figures will be 2.9 meters per second squared. 2.9. Okay, and I would say as a direction on that, forwards or positive, they never give me a direction in there, but generally you don't accelerate like that in reverse. Okay, reverse generally it tops out at about 15.
I think it's north, wasn't it?
Oh, did it say north? Oh, and I just missed it. North, absolutely. We should north there, because that's what it said in the question. Good eye. All right, questions on how that formula works? Okay, we only got one left. And there's only one of those formulas now that we haven't talked about. Okay, so write that one down, give it a try. Okay, so let's have a look at this one. Context-wise, okay, if you fire a gun, obviously the hammer comes forward and strikes the round of the bullet. Okay, that in there is where the gunpowder is. So that impact causes a spark inside that detonates, causes that gunpowder to explode. Okay, the explosion of the gunpowder creates rapidly expanding gases, which will then propel the actual bullet part of the bullet forwards. Now, if we're talking about a rifle, which it sounds like we are because it's 3/4 of a meter long, we're talking about a massive acceleration between when the explosion happens and the end of the barrel. That's the only time that bullet gets accelerated. Once the bullet exits the barrel of the gun, the pressure of those gases no longer pushes on it. You can see kind of the fire come out of the barrel behind the bullet. And then now the bullet is traveling through the air. Okay? And it spins. Okay? The barrel of a rifle has little grooves in it that cause the bullet to spin, which gives it a lower coefficient of drag, so it flies farther. Okay? So the acceleration is massive, because a bullet comes out of the barrel of a gun at an incredibly high speed, especially a rifle. Okay? Pistols don't have as much ability to propel because the barrel's shorter. So those gases don't get to push on it for as long. The longer the barrel of a rifle is, the faster the exit speed of that bullet will be, because the longer it gets pushed. Okay? That goes back to science 10, like work energy theorem, right? Work is force times distance. So if you got that force acting over a greater distance, it propels it to a higher speed. Everyone okay with that idea? Okay. So we've got, what would the initial speed of the bullet be?
0.
Yeah, we have to get that from the context of the question. It doesn't outright tell us that, but we can assume that here. We're looking for VF. It asks what's the speed it exits the barrel at. We know the acceleration, 5.35 times 10 to the 5 meters per second squared. That is an absolutely insane acceleration. And we also know the length of the barrel. That's the distance over which the acceleration happens. So 0.750 meters. Okay, so the only formula I have that has those four things in it is this one. And it's the only one we have left. Okay, we don't have the time in this question. It would be an incredibly small amount of time because the bullet's not spending a lot of time in the barrel. Okay, so I just need to solve for VF. Formula is set up to solve for VF squared, so the only thing I have to do is square root. Okay, so I'll go VF equals the square root of 0 squared, VI, okay, plus 2 times 5.35 times 10 to the 5 times 0.750. Okay, so punch that into my calculator. So square root of, okay, 0 squared, okay, plus 2 times 5.35 E5, okay, times 0.75. Okay, so the bullet comes out of the barrel of the gun moving at 896 meters per second. Okay, is that fast? Yeah. To give you context, this number is the speed of sound.
It's going triple.
Almost Mach 3. What does that mean if you're the target?
It's going 3.
You're dead before
You hear it?
you hear it. Okay? In the military, they have a saying, you never hear the bullet. Okay? You never hear the bullet that kills you because you don't hear the shot. You might actually hear the hiss of the bullet traveling through the air, but at that point it's too late. Okay? You're not going to register that before it hits you. Okay? So that's a little bit scary. Okay? Bullets travel faster than sound. That means someone can shoot at you and you won't know it until after. Okay? You actually see this sometimes in footage from the military, from snipers. Okay? They'll be taking shots that are gargantuan distances, and they'll miss. And in the camera footage, you'll see like you'll see the bullet hit the ground, and then you'll see people react like seconds later, because then they finally hear the sound of the shot. Okay? They don't realize they've even been shot at or that they were really lucky and the person missed until seconds later when the sound of the shot actually reaches them. Okay? So, yeah, a little crazy. Longest sniper shot, I think, is now actually held by a Ukrainian sniper. So the conflict between the Ukrainians and the Russians going on right now, it was before that held by a Canadian sniper. Okay? And it was nearly 4 kilometers. Okay? The Ukrainian snipers, I believe, is now more than 4 kilometers. Okay? It's hard to even see 4 kilometers. Okay? That is a vast distance over which to make a shot. Okay? Even traveling at, sniper rifles will usually fire at even a higher rate than this. Okay? But you think of how long it takes a bullet traveling at that speed to travel 4 kilometers. Okay, and we can do that calculation pretty simply here. Okay, so 4 kilometers, D divided by V. That bullet is in the air for 4.5 seconds after it's shot. Okay, so a person who can make a shot like that needs to be your friend, first off. Okay, you don't want them as an enemy, right? But secondly, needs to account for a lot of things. Okay, this is not something easy. Over 4 seconds of flight time, 4 kilometers worth of distance traveled. If there's a wind blowing across, can it move the bullet? Okay, and what else is the bullet doing the entire time it's flying? Dropping, because gravity is pulling it down towards the earth. And what's the earth doing under the bullet? It's spinning. Yeah, there's a Coriolis effect that even has to be accounted for in a 4-second flight time. Okay, so a person who can make that shot is accounting for all of those things and just a little tiny bit of luck. Okay, but you don't make a shot like that out of luck entirely. That is a calculated shot. Okay, you even have to go, all right, right now, when I pull the trigger, the person is standing there on the earth, but by the time the bullet reaches them, they'll be over here because the earth is going to spin and the wind's going to blow the bullet this far and it's going to drop this far. Okay, making a shot like that probably means that they would have to aim, 30 meters or more above the target. Okay, imagine trying to shoot at something that you don't realistically even see in your scope. Okay, now scopes have adjustments. We'll talk about that in projectile motion, okay, that allow you to move the scope. So the target is still in the scope, but the rifle's not actually pointed at them. Okay, you're moving the scope so that you can keep the target in the sight, but the barrel is not pointed at them. Okay, that accounts for all of these things. It is absolutely insane, okay, that a person can make a shot like that. All right, questions there? Okay. Let's say we try both of those. Do we need to make those bigger? Does anyone have trouble reading them? Everyone's good reading them? I don't need to make them bigger? Or would bigger be helpful? Okay, I'll leave them there. Give those a try. All right, let's look at the first one here, guys. So we have a jetliner that lands on a runway at 70 meters per second. That would be
Velocity
the initial velocity, right? So then we're going to have VI there, 70 meters per second. Okay. It reverses its engines to provide braking. You probably felt that if you've ever landed in a plane, you can feel like the sudden, they've got brakes on the wheels, obviously, but they also pop open all the flaps and then reverse the engines to create braking force. Okay, so it is going to do that 29 seconds later. Okay, it will come to a stop. Okay, so VF will be 0 meters per second. What's the jet's acceleration? Okay, which formula should I use for that? I got VI, VF, and T. I'm looking for A.
Oh, just acceleration is delta velocity over delta.
Exactly, the one you learned last year. That one will work here. I've got all that information, VF minus VI over T, right? I've got all that, so why not use it? So we'll have 0 minus 70, okay, divided by 29 seconds. That'll give us our acceleration. Okay, so 70, negative 70. Negative 70 divided by 29 seconds, right? So the acceleration there will be negative 2.4 meters per second squared because we only have 2 significant digits. Okay, and that fits. It's negative, it's slowing down. Okay, it's a reasonable number. What length of runway did the jet require to come to a stop safely? Okay, could I use any of the formulas at this point? Any of the ones that have D in them, I'm free to use. I have all of the information there. Okay, so you could use any of the ones you wanted. If it were me, I would probably go with this one. D equals VF times T minus 1/2 AT squared, but you could have also used VIT plus 1/2 AT squared. Okay, or you could have even used VF squared and VI squared 2AD, could use that one as well. Okay, this one just doesn't require me to do any manipulating, and this is 0, so I have the least amount of typing and stuff to do. So negative 1/2 times negative 2.4 times 29 squared, and I'll have the length of the runway required there. So negative 0.5 times negative 2.4 times 29 squared. Now, I didn't use the whole number here. I only typed in 2.4. Why? Because I've told you all the way along, always keep all the decimals in your calculator. Never round off. Why did I round off there? Okay, so important rule for significant digits. If you calculate a number in part A of a question, and you use that number in part B, you use the rounded value for part B. Okay, because you have a final answer. Okay, that final answer has to have the right number of significant digits. If you use that final answer to solve for a part B, you have to use the rounded value. Okay, just one of those rules that comes in sometimes with questions that have multiple parts. Okay, so it's about 1 kilometer, just over 1 kilometer, okay, of runway in order to stop. Okay, and we only have 2 significant digits there, so it would be 1.0 times 10 to the 3 meters, or 1.0 kilometers. Okay, how many people have done number 2? Okay, do we need more time on number 2? Okay. For question number 2, so on ramps. Okay, so like if you're getting on the Deerfoot out here, okay, and you're using that ramp, They are designed so that you can get up to highway speed before you merge. Unfortunately, not everyone realizes that, and it's really annoying, okay? When you get onto that straight section after the ramp, depress the pedal on the right, okay, and go fast. Because if you are that person who is going to merge onto a 110-kilometer-an-hour highway at 55 kilometers per hour, you are going to see Toyota in your rearview mirror, because I will be right on you. Okay, because I get really annoyed. It's really unsafe to merge onto a high-speed highway at a low rate of speed. Do not be that person. Okay? Yeah. Sorry, that rant was supposed to be inside my head. It came out. Sometimes that happens. Okay, so we've got, we want to increase our speed from 50 kilometers per hour. That'll be VI, but obviously we have to put that into meters per second. So 50 divided by 3.6, okay, 13.8. Okay, to 100 kilometers per hour, so that'll be like 27.7, something like that, right? So 100 divided by 3.6, 27.7, yeah. Okay, 27.7 repeating meters per second, okay? And the magnitude of the acceleration, and this is on average, right? It's, you know, on most ramps, it's downhill, so you get a gravity assist there, okay? 3.8 meters per second squared, okay? What's the minimum length of the off-ramp? All right, well, for that one, what formula should I use? What formula should I use?
Vf squared equals vi squared plus 2ab.
Exactly. Okay, because this is the only one that has the stuff I was given and the thing I'm looking for, d. So if I'm going to manipulate this one for d, first thing I want to do is subtract the vi squared over to the other side. So I'll have vf squared minus vi squared equals 2 times a times d, and I just want to solve for d, so I divide both sides by 2a, and I've got my formula. So I'll have 27.7 squared plus 13.8 squared, and I will use the non-rounded versions in my calculator, and then I'll divide that by 2 times 3.8. Right? That'll give me the minimum length of that on-ramp. So that number squared minus that number squared, okay, divided by 2 times 3.8. 76 meters long. Okay. Questions on that one? Okay. So remainder of today, I'm going to have you working on a few acceleration problems. Okay, obviously this week's quiz is going to be on acceleration, so these are your practice quizzes for this week. There'll also be some graphing in there, okay, so position versus time, velocity versus time, and acceleration. 4A, 5, and 6 are the ones you want to have a look at for this week. Okay, but what we're going to work on today and tomorrow is just acceleration problems, do some practice, you know, see where we're having trouble, and then Thursday we're doing the lab. Okay, we're going to run the carts down a ramp. Same equipment as the last lap, it's just we're going to elevate it this time, okay, and make them go and accelerate down the ramp. Okay, let's have you guys, for the remainder of class here, let's do 3, 4, 6, 9, 11, and 13. Okay, so if you work on those